This is crazy, scary time with Shay. All right, Mike asked me to do this for you guys because I have to work tomorrow, and he knows that you guys need your study time. So what I'm going to do real quick is I'm going to go over the endocrine system. I'm going to try and break it down for you, as he likes to say, like a fraction. So don't freak out if you can't see everything on the board, because he actually has a copy on a piece of paper that he's going to hand out to everyone. So first thing I want to do is I want to talk about the glands of the endocrine system. And so I'm going to try and write things on the board as we talk about it. The endocrine system has 1, 2, 3, 4, 5, 6, 7, 8, 9 different glands that I want to talk to you about. First gland I want to talk to you about is called the pineal gland. The pineal gland is a pine cone shaped gland, and it secretes melatonin. Melatonin is needed for sleep, so that's the first thing you want. Pineal gland, melatonin, sleep. All right. Then it also is responsible for the ovaries and the testes. And whether or not you realized it, it's also responsible for the placenta. All right, so let's break this down just a little bit for you. So when we're talking about the ovaries, we're talking about 2 types of ovarian cells. You have ovarian follicles, and you have the corpus luteum. Okay, both of those cells are important for the menstrual cycle and for sustaining pregnancy. All right, testes. I bet you guys can't guess what the testes are important for, but the testes are important for testosterone, and testosterone masculinizes. That's an A. Masculinizes. And promotes and maintains development of accessory male organs. Okay, so basically, this is what the testes are responsible for: producing testosterone, and it's the testosterone that's responsible for masculinizing and promoting and maintaining the development of the accessory male organs. That would be things like your testicles, your scrotum, things like that. All right. So one more little piece over here, and it's called the parathyroid gland. And the parathyroid gland, if you think of the thyroid as a little bow tie, on the sides of each thyroid gland, or the sides of the bow tie, there's 4 little dots. And it's those dots that are actually the, I was looking to see if you could see them, so I might need to make them bigger here. It's these dots that are actually the parathyroid, okay? And so the parathyroid, and remember, they come in 2 sets on each side of the thyroid. That's why, if you remember the pair, they come in pairs. So the parathyroid, and it's responsible for producing pTH, parapheromone. parathyroid hormone. Parathyroid hormone. And that is responsible for increasing the blood calcium level, and it does that by actually increasing the bone breakdown. All right, so I'm just going to repeat it again because I know that you guys are sitting here and you're listening to it, and it's a lot that's coming down, but I just want to make sure that you know. So far, we've really talked about 5 different glands. The first gland that we mentioned was the pineal gland, and the pineal gland produces melatonin, and melatonin is responsible for sleep. Okay? And then you have the ovaries, and there's 2 types of ovarian cells. That's what, let me try and move that over a little bit so you can see that. All right, 2 types of ovarian cells. Those ovarian cells are ovarian follicles and the corpus luteum. Both ovarian follicles and the corpus luteum are responsible for the menstrual cycle and sustaining pregnancy. Then we have the testes, and the testes are responsible for testosterone. Testosterone masculinizes and promotes and maintains development of accessory male organs. Something that I didn't mention was the placenta. The placenta is actually temporary, thank God. We don't have to carry that around permanently, ladies. And it's responsible for producing chorionic gonadotropins, which is the pregnancy hormones. Which, of course, when you want to be pregnant, you're glad that you have chorionic gonadotropins, and the placenta then sustains pregnancy. But of course, because like I said, it's temporary, when you're not pregnant, you don't have a placenta. Okay, and then the last one we talked about was the parathyroid gland. And remember I said that the parathyroid gland are 2 pairs of glands on either side of your thyroid, which if you think of your thyroid as a bow tie, then the parathyroid glands are these little dots right here. Okay? And the parathyroid gland produces parathyroid hormone, which is responsible for increasing your blood calcium level by increasing the bone breakdown. All right, now you have 2 huge glands. It's really one gland, the pituitary gland, but the pituitary gland has 2 sides. It has an anterior side and it has a posterior side. So the anterior side is like the mother of everything because it produces a little bit of everything for everything else. So I'm going to save that to last. And right now I'm going to talk about the posterior pituitary gland because it only produces 2 things. So over here I have posterior, sorry, my board is moving, pituitary. And it produces oxytocin, and it produces ADH, which is anti-diuretic hormone. The thing you need to know about both of these 2 hormones, oxytocin and ADH, is that both of them are actually produced in the hypothalamus, but they're released from the pituitary gland, from the posterior pituitary gland. So they're produced in the hypothalamus, but released from the posterior pituitary gland. All right. So what is oxytocin responsible for? Oxytocin is responsible for uterine contraction. That says uterine contraction. It's responsible for cuddling. That's why men produce oxytocin as well as women. that whole thing of when you're having sex and you're playing with the nipples and the nipples being an erogenous zone. When you do that, and I'm not advocating or not advocating, I'm just stating fact, is that when you do that, it releases oxytocin and it makes you want to cuddle. So they call it the cuddling hormone. And then lastly, oxytocin is also responsible for the release of milk in the milk ducts. Release of milk in the milk ducts. Post-pregnancy. Release of milk in the milk ducts post-pregnancy. All right. And then the ADH, we had talked about this when we went and we were talking about the kidneys, but I'll just bring it back to your memory, is that ADH is anti-diuretic hormone. Anti means against. Diuretic means peeing hormone. So it's against peeing, and because it is, it decreases urine secretion. All right. Just to recap, to make sure that you guys are tracking with me and that you're following me. So far with the endocrine system, we've talked about the pineal gland, which is responsible for melatonin, which is needed for sleep. Then we also talked about the parathyroid gland, which are a pair of glands that are on either side of the bow tie of the thyroid. And that parathyroid gland is responsible for producing parathyroid hormone, or parathormone, you might hear it called. And that's responsible for increasing the blood level of calcium by increasing bone breakdown. All right, then we talked about it, the endocrine system also being responsible for ovaries. The ovaries, there's two types of ovarian cell. You have ovarian follicles and corpus luteum. Both of those ovarian cells are responsible for the menstrual cycle and sustaining pregnancy. Along that same line of thought, we have the testes. Testes are responsible for testosterone, and testosterone is responsible for the masculinization and for the promoting and maintenance of the development of accessory male organs. Then lastly, we talked about this placenta, which is temporary. It produces chorionic gonadotropins, and that's needed for the sustenance of pregnancy. Then we said that another organ of the endocrine system is the pituitary gland, and we said that the pituitary gland itself is the mother of all glands, because from the pituitary many other hormones are released. So we divided that into the posterior pituitary, and then now we're going to divide it into the anterior pituitary gland. This anterior pituitary gland, it is a beast because it has so many things that it produces in and of itself. So here we go, and I'm hoping that I'm going to have enough room here to put everything. So, anterior pituitary gland, anterior pituitary gland. All right, so you have growth hormone, and growth hormone is responsible for an increase in size and rate of reproduction of cells. Of body cells. Okay? So, growth hormone is responsible for an increase in the size and rate of reproduction of body cells. Then you have melanocyte stimulating hormone. Bet you can't guess what that does. Okay, the melanocyte stimulating hormone causes rapid increase in the synthesis and spread of melanin. All right, then you've got these, you've got like 3 hormones that really deal with the whole reproduction system. But again, they're part of the endocrine system, and they are, they help to stimulate in both men and women. So I'm going to put it over here. You have the luteinizing hormone, or LH is what you see it as. Luteinizing, Luteinizing, luteinizing hormone. All right? And what that does is it acts with FSH, and we'll talk about that in a minute, what FSH is, but it acts with FSH to produce estrogen. And again, I know that I'm writing small on the board, but remember, Mike has this paper here for you, and you guys will be able to see all of this on a paper of your own. So don't freak at this moment. Just try and listen to it and take it in, all right? So it also LH, remember we're talking about luteinizing hormones, so we said that in conjunction with FSH, it stimulates estrogen. It also stimulates progesterone. And it stimulates testosterone. And really what it does is it stimulates the interstitial cells of the testes to produce testosterone. Stimulates testosterone. So luteinizing hormone, it acts with FSH to produce estrogen. Luteinizing hormone stimulates progesterone and stimulates the interstitial cell of the testes to produce testosterone. That's luteinizing hormone. Then we have FSH, which is follicle stimulating hormone. All right? And what follicle stimulating hormone does is that it's responsible for growth. I'm going to let that ambulance go by. It's responsible for the growth of ovarian follicles, and the stimulation of estrogen. And testosterone. All right, so you remember I said that there's 3 hormones from the anterior pituitary gland that all deal with the reproduction system. We talked about luteinizing hormone, that was the first one, and that was responsible to act with the follicle stimulating hormone, or FSH, for the stimulation of estrogen. Then luteinizing hormone also stimulates progesterone and testosterone. And then the FSH, or the follicle stimulating hormone, is responsible for the growth of ovarian follicles and stimulation of both estrogen and testosterone. And then the third hormone from the anterior pituitary gland that I want to talk about that is associated with the reproduction system is the prolactin. Prolactin. And as the name sounds, pro means for, and lactin means lactation. So prolactin is responsible for milk production after birth. It sustains milk production after birth. Okay, now here's where you might get a little confused. You have prolactin that comes from the anterior pituitary. It sustains milk production after birth. And then you have oxytocin, which comes from the posterior pituitary, and it's responsible for the release of the milk in the milk ducts. So basically what has to happen is the prolactin has to sustain the milk production, and then once prolactin sustains the milk production, oxytocin takes it and releases it into the milk ducts. All right? So now we're left with basically two more hormones that the anterior pituitary gland secretes. And I'm going to erase the board so that you all can see these last two because they contain a lot in and of itself. So again, don't freak because Mike does have everything that's on here written down for you. So it shouldn't be a big deal. While I'm erasing it, we're going to review again just to make sure that you guys have it. The endocrine system, we talked about the pineal gland. The pineal gland produces melatonin, which is responsible for sleep. Then we talked about the parathyroid gland. Remember that if you imagine the thyroid as a bow tie, the parathyroid gland has, there's a pair on either side of that thyroid, and it produces parathyroid hormone or parathormone, and it increases blood calcium by increasing bone breakdown. Then we said that there are three glands of the endocrine system that deals with the reproductive system. Now, before I told you that there were 3 hormones of the anterior pituitary. That's not glands. Make sure you don't get those confused because there's 3 glands of the endocrine system that deal with reproduction. There are the ovaries, the testes, and the placenta. All right, the ovaries have 2 types of cells. They have the ovarian follicles and the corpus luteum. And they are responsible, the corpus luteum is responsible for progesterone. The ovarian follicles are responsible for estrogen. And estrogen and progesterone together are responsible for sustaining the menstrual cycle and sustaining pregnancy. Then we said that the testes were responsible for testosterone. I think that's probably going to be the easiest of everything because the name kind of gives it away. So testes are responsible for testosterone, which masculinizes and promotes and maintains the development of accessory male organs. And then we said that the placenta was a temporary organ of the endocrine system, and it produces chorionic gonadotropins, and that is responsible for sustaining pregnancy. And then the one endocrine gland that we said was the mother of all glands was the pituitary gland, which we divided in 2 parts, the posterior part and the anterior pituitary. So we said posterior has 2 hormones, oxytocin and ADH. ADH is responsible, ooh, that's scary, sorry. ADH is responsible for a decrease of urine secretion, and oxytocin is responsible for 3 things: uterine contraction, the cuddle hormone, and the release of milk into milk ducts after the anterior pituitary gland stimulates prolactin, and prolactin sustains the milk production after birth. All right, so let me put this anterior pituitary on here again because we are not done and I ran out of room. So here I have the anterior pituitary, and we talked about the growth hormone, we talked about the melanocyte hormone, melanocyte stimulating hormone. We talked about the 3 hormones for reproduction that comes from the anterior pituitary. And those are, I hope you can say it as I say it, luteinizing hormone, or LH, FSH, follicle stimulating hormone, and prolactin. Out of these 3, the only one that men do not have is prolactin. And that's because prolactin is responsible for sustaining milk production after birth. But the luteinizing hormone and the FSH, both men and women have, because they help to stimulate testosterone. All right? LH, the luteinizing hormone, again, it acts with the FSH to stimulate estrogen. It stimulates progesterone, and it stimulates testosterone. FSH, we said, is called the follicle stimulating hormone, and it's the growth of ovarian follicles and the stimulation of estrogen and testosterone. So then the last 2 that I said I really wanted to talk to you guys about were, this is the anterior pituitary gland releases TSH, which is called thyroid stimulating hormone. All right? So the thyroid stimulating hormone, by the name, tells you which organ it stimulates. It stimulates the thyroid, which is responsible for metabolism, temperature, and parts of the nervous system. The TSH produces or stimulates the thyroid to produce T3 and T4. T3 is called triiodothyronine. Triiodothyronine. And T4 is thyroxine. Okay? So let me just give you, and it also produces, the thyroid does T3s and T4s, and it also produces calcitonin. So calcitonin and the parathyroid gland, they kind of work together, because calcitonin, whereas the parathyroid gland increases blood calcium by increasing the bone breakdown, calcitonin decreases blood calcium by, you guessed it, decreasing or stopping bone breakdown. Okay, so just so that you know it again, I'm just going to say it again. Calcitonin decreases blood calcium by stopping bone breakdown. That comes from the thyroid, which gets stimulated by TSH, or the thyroid stimulating hormone. Whereas the parathyroid gland is responsible for stimulating, or it's the parathyroid gland produces parathyroid stimulating hormone, or parathormone, and it's responsible for increasing blood calcium by increasing bone breakdown. Calcitonin is thyroid, and it decreases blood calcium by stopping bone breakdown. Parathyroid hormone increases blood calcium by increasing bone breakdown, and calcitonin decreases blood calcium by stopping bone breakdown. Okay? So let's then concentrate on this TSH and the thyroid gland producing T3s and T4s. The way that works is it's called a negative feedback system. And the whole thing works like this. Your thyroid, for lack of better analogy, your thyroid is asleep. And so TSH, the thyroid stimulating hormone, sends out the anterior pituitary gland sends out some thyroid stimulating hormone, and it goes to your thyroid and it says, hey, wake up, it's time to produce T3 and T4. T3 and T4, the thyroid is still asleep, so it's not producing T3 and T4. So then the anterior pituitary gland sends out more TSH. And now there's 2 or 3 or 4 or 5, there's more TSH coming, and it goes a little bit louder. Hey, thyroid, wake up, it's time to produce T3 and T4. And so it wakes up and it produces a little bit of T3 and T4, but not enough for it to do anything. So now the anterior pituitary gland sends out even more TSH, and now it's like, hey, wake up, thyroid, produce T3s and T4s. And so then T3s and T4s start producing in mass quantities, and as T3s and T4s increase, TSH decreases until there's so much, until there's T3s and T4s. When those levels start to drop, then TSH level starts to increase again. So that's called a negative feedback system, because as one increases, the other decreases. That's negative feedback system. All right? TSH comes out, stimulates. So TSH is here. It's stimulated T3s and T4s. T3s and T4s come up. TSH starts to go down. T3 and T4 goes down. TSH starts to come up. Negative feedback. Okay? All right. Whew. All right. So that is the thyroid. So the anterior pituitary produces TSH, which stimulates the thyroid to produce T3s and T4s. All right? It also produces calcitonin, but we grouped calcitonin as the opposite of the parathyroid. Remember that. Parathyroid hormone increases blood calcium by increasing bone breakdown, and calcitonin comes from the thyroid gland, which is stimulated by TSH, which is produced in the anterior pituitary gland. And calcitonin decreases blood calcium by stopping the bone breakdown. All right, so again, parathyroid and calcitonin are negative feedbacks, because as parathyroid hormone increases, calcitonin decreases. As calcitonin increases, parathyroid decreases. That negative feedback system. Positive feedback system is when they both move in the same direction at the same time. All right? Okay, so far we talked about this anterior pituitary gland, and we said that it produced the growth hormone, which is responsible for increasing the size and the amount of reproduction of body cells. If it goes awry and it starts to produce too much, then we have gigantism. If it doesn't produce enough, then we have dwarfism. Then we have melanocyte stimulating hormone, and that increases the synthesis and the spread of melatonin. Okay? No, not melatonin, melanin, sorry. The spread of melanin. Okay? Then we have the 3 hormones from the anterior pituitary gland, which are the luteinizing hormone, the follicle stimulating hormone, and the prolactin. Men do not have prolactin, but they do have LH and FSH. Prolactin stimulates the milk production after birth. So remember, pro means for, lactin means lactation or milk production. So for milk production, prolactin. All right? FSH, we said, was responsible for the stimulation of estrogen and testosterone, and it's also responsible for the growth of ovarian follicles. Hold on real quick. Mike is giving me notes as I'm teaching. You just have to turn it on the side.
Got it.
Okay?
How much time we have left on that?
I don't know. I've been here for 34 minutes.
Okay.
Okay. All right. So the last one that I want to talk about is I'm going to erase this because it's in my way. And I'm just going to put TSH over to the side. TSH. And then the last thing that I want to talk about is the ACTH. ACTH. And it's the adrenocorticotropic hormone. Adrenocorticotropic hormone. ACTH. Adrenocorticotropic hormone. Adrenocorticotropic hormone. And this, just like its name says, stimulates the adrenal glands. All right? And the adrenal glands, the way I remember this is the adrenal glands are responsible for sugar, salt, and sex. All right? Sugar from glucocorticoids, salt from mineral corticoids, and sex because it produces androgens. All right? Glucocorticoids are responsible for maintaining blood sugar because the glucose, that gives it away, so it maintains blood sugar. And it helps to maintain blood pressure. Normal BP, blood pressure. Mineral corticoids, they increase blood sodium and they decrease blood calcium. So mineral, salt is a mineral. That's how you put those together. Sugar, glucocorticoids maintains blood sugar and normal blood pressure. Salt maintains the mineral corticoids, and that increases the blood sodium and decreases blood calcium. And then it regulates sex. The adrenal glands regulate sex by producing androgens. And both male and female have androgens. Okay? And then on top of these adrenal glands, you have the adrenal medulla. Adrenal medulla. And the adrenal medulla is responsible for producing epinephrine, and norepinephrine. All right? And both of those, epinephrine and norepinephrine, it helps us to resist stress, and it helps us to increase the effects of the sympathetic stimulation. So it increases the effects of sympathetic stimulation. So if you remember from your nervous system, sympathetic nervous system increases your heart rate, it increases your blood pressure, it increases your acuity, your strength, okay? So the adrenal medulla, which produces epinephrine and norepinephrine, helps to increase the effect of the sympathetic stimulation of the nervous system, okay? All right, now, if you give me just a second, I will look in my computer and make sure that I've covered some of the things that I need to cover. Just give me a second here to pull it up. I probably should have done that before I started recording. But it is what it is, and I'm sure you guys will understand. Okay, nice screenshot. At least you don't have to look at me, and that's better than anything. I'm almost there. Just log it in real quick, and then I'll get to where I need to go. Okay. Okay, so we talked, here are some things that I wanted you to know, but I didn't tell you. Things like the difference between, in the endocrine system produces prostaglandins and it produces hormones. What's the difference? Well, the difference is that both prostaglandins and hormones produce chemicals or chemical messengers, but prostaglandins are found in the skin and they're localized, whereas hormones can send messages to areas that are far apart from each other, like the anterior pituitary gland all the way down to the adrenal glands, which are on the top of the kidneys. All right? So we know that the endocrine system consists of glands that release chemicals carried by the blood. We know that. And we know that hormones regulate metabolism, they regulate blood pH, but they don't really regulate voluntary muscle movement. That's something that you really need to understand. Okay. When we talked about the hormone system, we talked about prostaglandins and we talked about hormones. There is a type of hormone called non-steroid hormone, and those are really called the second messengers, okay? And that's really like non-steroid hormones. Second messengers are important in the functioning of non-steroid hormones. And they have hormone receptors. These non-steroid hormones have hormone receptors in the cell membrane. And they cause the formation of CAMP, C-A-M-P. Okay? So those non-steroid hormones, just remember that second messengers are important in the functioning of non-steroid hormones, that the non-steroid hormones have hormone receptors in the cell membranes, and that they can cause the formation of CAMP. Whereas steroid hormones have hormone receptors in the nucleus, and they cause protein synthesis in the cell. Remember, non-steroid hormones cause the formation of CAMP, and it happens in the cell membrane, or the hormone receptors are in the cell membrane.
What happened?
Nothing happened.
Did it turn off?
No, it's still recording.
Okay, can you pause it for a second?
I don't know how to pause it.